So our guest today is Anil Nanduri. Anil holds two very important roles within Intel Corporation. He's a vice president and leads the AI acceleration office for the CEO. And he's also the general manager for the data center AI category and is working very closely with NielsenIQ on our AI plans. Anil, welcome to the podcast. Tell me more about your journey in technology, how you sort of found yourself leading up the AI acceleration office at Intel. I want to know more about Anil.
Hey, thanks, Zoe, and thanks for having me here. It's great to talk about AI, and it's a fascinating, evolution. Intel, if you kind of see, is very uniquely, positioned in terms of what we do. The world knows us for building processors for PCs, and our CEO wanted to ensure that our AI efforts are integrated into everything we do, including how we use AI internally. So from our IT, from our design, we do a lot of high performance simulations. From manufacturing, how can AI be leveraged into our technology? So he formulated the AI acceleration office, kind of a cross Intel effort to actually drive the adoption and acceleration of AI across multiple domains. And I've been working with the AI Acceleration Office for the last year and a half, and fortunate enough for them to ask me to lead it. And it's a great opportunity at the same time, being able to be at a front hand, kind of first hand driver's seat of watching this ecosystem evolve. As far as my background, I'm crazy about tech. I've been here over 25 years. I was a key part of the team that drove the adoption of Centrino, which is when we brought PC technology and Wi-Fi together. And now Wi-Fi is ubiquitous, right? Who would think of a laptop without a Wi-Fi in there? But back in the day, that's how we had to kind of drive those forward. And then I got into the GPU technology and the data center side of the business. So I've done multiple roles across Intel, and everything was at the cutting edge of technology, if I could say it that way, and bringing in new capabilities into both customers as well as into the ecosystem.
When you reflect on your experience, whether at Intel specifically or within technology more broadly, do you feel that there's something in your background that made you well suited for the role that you find yourself in right now?
I'm always fundamentally driven by the first principles, if I had to say, understanding the why, understanding the what, and understanding the how, right? You could have the best technology in the world, but if it's too expensive, it's not going to scale, right? Or you could have technology, and by the way, learned through my career itself, you had too early, a technology, and the ecosystem is not right and ripe to scale it. Everything that I've done or aspired to do is about scale. How can you impact the maximum amount of people, and bring new capabilities that improve our lives, right? And that's actually Intel's DNA as well, right? How can a piece of silicon, and then that's what Intel does, build silicon, right? How can it impact and touch upon the billions of people worldwide? I mean, there's so many pieces that work on top of that silicon, whether it's the operating system, the software, the applications, the use cases, this video chat that we are doing right now, right? It's built on that little silicon. And so how do you bring these experiences together? AI is no different world. Now we have a very promising technology here. How does it help us improve our lives? How does it help us improve our productivity? How does it help us to get to do new things that we couldn't do before? So that journey continues to evolve, and it's not the complexity of it, it's the applicability of it.
What would your advice be for people who are trying to break into these sorts of AI focused technical roles or trying to break into this technology, but they feel like they just don't have the background. They don't have the bona fides. Maybe they don't come from the same deep technical background that you come from.
So I think my advice would be for every person is leverage the tools that are available, and then start at a point where you have the comfort level, right? And where do you see, but it all starts with the curiosity to learn.
Yeah.
Now, AI sounds complicated, but if you kind of look back in time, AI work has been going on for probably a half a century, like 5 decades or so. Okay, it's only recently that the Chat GPT phenomena came about. AI suddenly became the next big thing. In 2017, a paper got published called "Attention is All You Need." It's some bunch of brilliant scientists that are part of Google and DeepMind that actually wrote that paper. But what they really did was they kind of, this is what you call the word transformer architecture. So think of it as they just developed a faster, more efficient architecture to do some of the AI processing, and which is being able to help get the semantic understanding of language in a very easy way to be trained, so that people, you could talk to computations, computers, with a way on how you would normally converse. So that literally is what a large language model does, is it understands how we humans speak.
Hmm.
So what this attention is all you need helped us do is that, how can I now have some kind of a software that can actually understand the way we understand it? That's
Hmm.
literally what ChatGPT has done, right? Now, how does it work computationally? You just have to step back and look at what it does. And AI is a series of matrix multiplications. So you're giving a bunch of inputs. Think of them as neurons in our brain. That's how we process. And then it connects to a next set of neurons, and it connects to another set of neurons. And so each of them is processing some parts of the information in different ways. We have sensors that are connected. We see, we hear, we taste. And so it's just in that same context. If I break it down computationally, you want to be able to take these inputs, you want to put them into matrices, connect them to a next set of matrices, and connect it into a bunch of next set of matrices. What does it really transform to? A whole bunch of matrix multiplication. So
Yeah.
for any
Yeah.
10th grader in math would know what matrix multiplication is. It's a series of that, and just exponentially complicated.
I went to a subpar school, Anil. I didn't actually learn what matrices were, or if I did, I've completely forgotten that information. So let's pivot then to the computation. Can you explain a bit more about how GPUs became so intertwined with AI? I have a team of researchers who work for me, and they're always talking about access to more and more GPU technologies. Why is a product that is marketed towards giving you breathtaking graphics on your computer monitor so intertwined with artificial intelligence?
Like a very good question, right? And you're looking at gaming, especially. You're getting all these role playing games and multiplayer games, and very visually enriching. How are they created? And since your human eyesight looks at 30 frames a second, and you want to be able to see it faster, these things run at 60 frames a second or 120 frames a second. So you can't computationally do one side of a screen and then build your way out to the end of the screen, right? So they're all done very parallel.
Yeah.
It's called vector math, very well defined in computer vision, and so that's the math behind it. AI is similar. I told you earlier about matrix math, and it's also very parallel, right? It's very computationally intensive. You don't do AI sequentially. You're going to run a lot of these pieces together parallelly.
Hmm.
Now, if I told you that these AI chips, that the GPUs that we talked about, the GPUs you build for great gaming is not exactly the GPU you do for AI. It's just that they don't in fact have any of the visualization blocks in the GPU anymore. They only have the matrix engine primarily and the vector engine. It's the same card that powers Chat GPT is not the card that you would play a game on, right? So they've taken off some of the features you don't need so they can make it more efficient just for AI.
There's the GPUs that are consumer facing, which are intended for gaming, for fantastic, graphics on your computer monitor or your television. And then there's a separate class of GPUs where they've taken away the bits that are not necessary to render a game engine and just said, here's what remains. The core of it is just math.
Yes.
These GPUs will be purely positioned towards enterprises and folks with a lot more money than just your average consumer trying to run a game.
think of it as data centers. I mean, you don't connect a display to a data center, right? So anything that you need to visualize and connect a display and you interact as a person, that needs some element of the GPU function, right?
Right. And it's
But when you're
superfluous
just
AI.
yeah, but when you're just doing computations, you don't need all that function. So basically, what is left is the computational part of it. And then so that's how the transition to GPUs happen. Now, are they the most efficient for AI? That's a big debate within the research community. But one thing I can say is that they've at least shown from a using the software side of things that it's the most adaptable right now, but it may not necessarily mean it's the most efficient, right?
Yeah. Okay. Okay. And you used to be a chip designer as well at
Hmm.
Intel. You got involved in.
Yeah.
Okay. So I'm going to use that as license to geek out even more. Is the difference between a CPU like Intel's Xeon, or its entire sort of pedigree before that, versus a GPU? Is it that the CPU is sort of an all-purpose Swiss Army knife? It has hundreds of these op codes that say, do some multiplication, do some addition, do some subtraction, do some division, move this digit over by one place, those sorts of things, and do them incredibly fast.
So if you think about if you have to manage a database, okay, and you have tons of data, CPU is best for it, right? You're not going to have to do anything differently. But if you have to do graphics on a CPU, you can do some element of it, but it won't be as fast as you want it. So you need something that is more parallelized. And so the good thing about the CPU is everything can be done, but then it may not be running the most fast. In fact, even AI, all these matrix multiplication, in fact, you'll be surprised. Xeon supports a lot of them. It's just that at that scale and performance you need, they don't scale as efficiently as a GPU, right? So think of CPU as, it's ubiquitous. Think in that context, or a car versus a train, right? A train can take a lot of people from one point to the other. That's actually a good way to think of a GPU. While car is flexible, I can go, but I can't take as many people.
Right. Now, are there other methods by which people are starting to sort of crack this problem rather than using purely GPUs for AI applications? Intel's got a Gaudi product. They also have another product called Loihi. Apple markets their M1, M2, M3 chips. They all have sort of these neural engines.
So you have three computational blocks, all efficient, and they turn on only when you need it.
Mhm.
So when you're gaming, the CPU is not as running as much. And when you're running the CPU, the gaming side of it, the GPU is idle. So that's how you kind of make it efficient, and it kind of does the best job for what the user wants to do. When it comes to AI now, yes, I can use my GPU to do some of the AI. I can use my CPU to use some of the AI, but AI is computationally very high power. And so the neural engine is, again, a dedicated set of logic that just does matrix multiplication very efficiently. So when I have to do just matrix multiplication, why don't I move all that to a part of a chip that can do it really well? So why do they call it neural engine? Because they want people to think about it as neurons is what gives us intelligence. And so neural engine is what is giving intelligence. So the AI part of it makes it easier for people to kind of think of, hey, if it has a neural engine, that means it has something unique about AI in it.
Yeah. Okay, that makes sense. Now, given what you just said, do you think that GPUs and AI are now sort of on their own paths going forward, or do you think that the GPUs and these neural engines, these AI accelerators, that they will continue to sort of develop together and be strongly coupled together?
I think you will the way I would look at it is there's a phase of how ecosystem is so dynamic right now. So there's a lot of, kind of learning still going on. And so I think AI is that beginning part of the journey. Now there's also debate about what is the right computation for AI, right? Today, vector and matrix math is one way to do it. But if you think of how humans interact, our neurons are not super fast, but they're super effective. Okay, the human brain consumes very little power. Okay, and yet, to get that same power of a human brain, I need gigawatts or megawatts of power in a data center, right? So, how is the human brain able to achieve it? And so this is where the technologies, whether it's quantum or neuromorphic computing, people are going to research into saying, is there a better way to do AI computations differently? But if I go back into my decades of experience in technology, these evolutions happen. They happen every 5, 10 years. You see them, new capabilities adopt, and they get better and better. And so, that's what we believe in. It's computationally, that's what Moore's law is all about.
It's kind of interesting to sort of juxtapose the fact that we're at the beginning of this journey, but if you take a wider view of it, if you broaden the aperture, you go back all the way to, like, I think it was the 1960s with Dartmouth and sort of the advent of artificial intelligence and how that, slowly became machine learning, and then that became neural networks, and that became deep learning. So we're kind of at, like, I don't know, like a year 60 something in the journey, but we're also like at the beginning. We're always kind of trailblazing these new frontiers. So it's always exciting to see, what's coming down the pike in terms of the next generation of advances.
We didn't touch about spatial computing. That's how people in the real world interact. And so when that is also a lot of work going on there, there's augmented reality and mixed reality. And when you bring that and combine artificial intelligence and robotics, you start to see a whole different computational element, which are sensory driven, right? And so they have a different set of math to move it to process very quickly.
Our teams at NIQ have been experimenting quite a bit with machine learning and artificial intelligence. We've got like a 25-year history of sort of working with various incarnations of these models. And you've mentioned transformers earlier, and we've been using transformer models as well. One of our most common use cases is this idea of product attribution or item attribution, right? You give me some product for sale in a grocery store, in a store, period, and I have to tell you the attributes of that product. You give me this can of soda, and I have to tell you, well, the brand is Coca-Cola. The can size is, this many fluid ounces. It's a diet soda, or it's got, full sugar, whatever those sort of attributes and characteristics are, they become really, really important for our customers because they want to know how they're doing in a particular category. Now that we have these e-commerce reads and omni reads, we get something like 30 million, 25, 30 million new products added to our global database every single year. And on average, we have something like 20 to 30 attributes per product. And what that means is on a daily basis, we're doing this thing called item coding a million times every single day. And because of the volume of information that we've been getting, we've been using transformer models, right? So what we'll do is we'll say, if you give me an e-commerce product description, I can predict for you what category it belongs in. We've been doing that for a couple of years now, since before Chat GPT had ever sort of made its big splash. We started to realize that this could become a fairly expensive endeavor, and that these models are sort of trained on this corpus of the whole of human knowledge. And did we really need the whole of human knowledge to make this sort of a prediction? So we built our own language model essentially from our own data, and it didn't have the ability to have a conversation with you and like teach you a new topic. You couldn't engage with it on that level. But if you gave it a product description, you didn't have to give it three choices. Just give it the description, it'll give you the category, and it would do it better than the combination of that transformer and that large language model. Now, we've been working with Intel on actually taking that model, which is fairly small right now. We're trying to scale that to something that's in the tens of billions of parameters. And technologies like Intel's Gaudi are really key to us being able to accomplish that. Can you can you tell me more about how the Gaudi differs from some of the other solutions that are on the market? And I'm also a little bit curious about what this Loihi thing is that I've read about as well.
So let's break down Gaudi. Now, for what Gaudi was actually is perfectly built for this transformer architecture. Okay, so it has a reasonable amount of programming, like a GPU. But then the only difference is it has its own compiler. But other than that, it's capable of doing everything that this Gen AI domains require. Now, the good thing is, since Gaudi is not a straightforward GPU. It removes a lot of the overhead, as we talked about earlier. So it's actually runs some of these very efficiently. Okay, so it's an accelerator that can give you, both performance and power efficiencies and cost efficiencies, which is very important. Like you said, it's becoming cost prohibitive. So Gaudi gives you that little bit of a specialized, yet the flexibility of doing all the AI programming, but the benefit of a TCO benefit, right? We've already claimed, 2x TCO to a competing GPU in the market. Now, what you don't need is, if you kind of ask a GPT today, or Gemini, or Llama for that matter, with Meta AI, you can ask it to give you an itinerary. It can ask you to give you a trip report. It can ask you to write an essay. It can give you a subject domain. How is it able to do that? It's able to do that because it trained on all this data, right? And it trained on web crawl data. Now you don't want those models that are sitting out there to train your data. For Nielsen IQ, your consumer data is your biggest IP, right? And you don't want that data going out your domain, your own firewall for that matter. You want it to be in your full control, but you want to augment it with human understanding. So, and to just do the human understanding part, you don't need, kind of a, 1 trillion parameter model. Llama 2, 70 billion, was what was kind of one of the, leading edge models. And now you have Llama 3, 8 billion, which means there's almost a 10x reduction in number of parameters. But the accuracy of the smaller model is as good as the old model. So you're seeing rapid innovation where models are getting very efficient. So you will soon have a model that is specific for what you need for semantic search, that is available in open source, and that can be small. And you can then combine that with the data that you have and have your own, think of it, Nielsen IQ custom model, which is not only got your data in transformer, but also some element of language understanding. Or there's different ways to connect them, so you can get the language understanding from one model, but then you can feed it through something called retrieval augmented generation, which is basically keeping your data in a different zone, but using the model just to understand English. But then the data that you connect is going to be your own. So you keep it proprietary. So there are techniques that are evolving for enterprises to how to best leverage this without compromising your data IP, your data security, as well as your business models that you want to evolve, and yet get the benefits of what AI can do for your business. And where Gaudi really helps for in this scenario is, one, to help you accelerate it at a much more lower TCO, and get you the value that you can then, because it needs to fit your business model. And so that's what I'm super excited about. The partnership that we have is to kind of prove that whole end-to-end use case and build it out. That's what goes. Now, as far as Loihi, which is our neuromorphic chip, it's more in the research domain. And so there's a lot of excitement there, ability to do computations differently than typical, like I told, whether it's a vector math or scalar math. Loihi does math differently. It's a different kind of computational element. So is quantum. Quantum has elements of predictability built into it because it is not constant. So you're trying to control, a spin of an electron to decide whether, is it going to, be on this side. So there's a a probability built into those kind of computationals. So they will be suited for, like, say, people say, like, for crypto work and, crypto technology for passwords and, security. It's no better time to be kind of in the chip industry or in the in the algorithmic industry, where it's a renaissance of architectures that are evolving. And so it's good to see that wave of excitement in the ecosystem where new architectures are being researched, tested, evaluated. And I think the future looks very bright that that there will be something, the next generation of computation, the next breakthrough will come through.
Thank you, Anil. Again, it's been an incredibly engrossing conversation.
Thank you, and it was great. It was a wonderful conversation, and and thanks for having me on your show.
And thank you as well to our audience for joining us for another episode of Accelerating Impact. We look forward to engaging with you guys in the comments.